So recording is started. Good morning, all of you. This is a class of Geotech Engineering, Module 2. So in the last class, we have started the new chapter, that is permeability of soil. Okay. So in the last class, if you remember, we have discussed about the basics of permeability. That is, what is permeability? So permeability it is what? Permeability is a property of soil that allow the passage of water or any kind of fluid through the interconnecting voids within a soil mass. Okay, and it is given by the Darcy's law. Okay, and it is known as a Darcy's law. And Darcy's also have given the statement that the discharge or rate of flow, okay, rate of flow or discharge per unit time is directly proportional to the hydraulic gradient and directly proportional to the cross sectional area perpendicular to the flow. Okay, so finally we have got the Darcy's formula, that is Q is equal to KIA, where K is your coefficient of permeability. Okay, okay, first let me share my screen. So visible, right? My screen is visible. So yeah, so in the last class, from the last class we have got this formula. What kind of formula I'm talking about? This formula, Darcy's formula, that is, sorry, wait. Darcy's formula, that is your Q, sorry, this is Q, okay. Q is equal to K I A, okay. So this is Q, okay, this is Q. Q is equal to KIA. Q is your rate of discharge or discharge per unit time or rate of flow, whatever you say, which is proportional to the hydraulic gradient and cross-sectional area perpendicular to the flow. And when you replace the proportional symbol with a equal symbol, so it will be come like Q is equal to KIA. এক সেকেন্ড হা কে মই ক্লাছত আছোঁ মই কৰিছোঁ তোক হা কৰিছোঁ কো কৰিছোঁ Okay, so Q is equal to KIA, where K is your coefficient of permeability. Fine. So today in today's class, we are going to determine, or we are going to find out how to determine this, that is K, that is how to find out the value of K in laboratory. Okay. So this K is representation of coefficient of permeability. Okay. So we have two laboratory test that we are going to discuss today. Laboratory test for determination of coefficient of permeability, that is the K. Okay, fine. So the first test is your constant head flow, or simply constant head permeability test. Okay, and the second one is your falling head flow or falling head permeability test. Okay, so we have two tests, or you can say two laboratory tests that can be used to find out coefficient of permeability, or you can say in general permeability of soil. Now why we need two different laboratory tests, that will be question will may arise here. But what is the significance of these two tests? In general, this constant head test or constant head permeability test is used to find out coefficient of permeability for coarse grained soil. Okay, and that falling head permeability test is used for fine grained soil. Here you can see written here. Okay, falling head permeability test or falling head permeameter is recommended for fine grained soil. Okay, I think regarding related to fine grained soil, coarse grained soil, it is already clear to you in the last module. Okay, if you have still doubt, you can go back to that particular previous class notes or class recording video, so you will get the very difference between fine grained soil and coarse grained soil. So likewise, this constant head permeability test is recommended for coarse grained soil. Okay, so this is the basic difference between these two tests. Fine. Now one more difference is there technically. Here you can see the name itself, it says the difference. Here you can see the constant term is added here in the first test, that is constant head. Okay, and in the second one it is represented as falling head. Okay, from there also we can find out another difference, that is in this particular test your hydraulic head or simply the head is or head difference is constant. Okay, head means I think you have got this idea, like hydraulic gradient is constant. Okay, that is the head due to which the water flow, that head, it is constant in this particular first type of laboratory experiment, that is constant head permeameter or constant permeability test. In case of falling head test, the head is not constant, it is decreasing or falling. That's why its name is as falling head permeability test, and a apparatus also known as falling head permeameter. Okay, this is the very basics to difference between these two approach or method for determination of coefficient of permeability. Okay, now also it has some two formula to find out the value of K. This formula, here you can see this formula, that is K is equal to QL divided by AH. This formula is used to find out coefficient of permeability, that is K, for coarse grained soil, which is under this constant head test. Okay, and under falling head test we have another formula for K. This one, K is equal to 2.3 L into small a log 10 H1 by H2 divided by capital A T2 minus T1. Okay, this is the formula for determination of K, that is coefficient of permeability for fine grained soil, which is done by using this falling head test. So don't worry about that. We are going to discuss about that. What is L, what is A. Okay, I'm just giving you just overview. Okay. So here you can see the diagram here. A simple line diagram is showing here to um, for more clarity of the constant head test. So what we do in constant head permeability test, once pre-decided soil sample of known length and known cross-sectional area. Okay, this L is the length of the sample, and cross-sectional area, we cannot see the cross-sectional area, that is capital A. It is an perpendicular direction. Okay, in this direction. Okay, so this known this soil sample, that is you can say that this coarse grained soil sample having length of L and cross-sectional area of capital A, it is sandwiched between two water tanks. One is at the top and one is at the bottom. Okay, the bottom tank is somewhere here. Okay, so from this top tank, or you can say overhead tank, from this overhead tank, a continuous flow of water is allowed through the soil. Okay, a continuous passage of water is allowed so that water can pass through these, okay, permeable membranes. Here permeable membranes are fitted here on the both side of the sample, and water is allowed to pass through this sample, and finally water will come out of the sample in this direction, and it will fill in the bottom tank. Okay, so bottom tank will be somewhere like this. I'll show you. Maybe bottom tank will be like this. So water will be filled in this manner. Okay, after that, this after this bottom tank, one measuring tank, or you can also add here measuring tank. This is a measuring tank where the overflow of the water from the bottom tank can be stored in this measuring tank. Okay, okay. So can you is it visible, right? So I just got some confused here. Is it visible? My screen is visible. Screen is visible, right? Please do respond. Am I audible?
Yes, sir.
Okay, take it, take it. Okay, okay, fine. Wait. Okay, so here what I'm just we are discussing about constant taste. So this sample, soil sample, is fitted between two tank. One is at top, one is at bottom. Fine. So the continuous flow water is allowed to pass through this sample, and finally this water is passed through and come out of this outlet pipe and stored in a particular measuring tank. Okay, and it is known as small q. What is small q? It is a rate of discharge. Okay, that means the water coming out of the sample within a definite time. Okay, definite time means you can take any time, say 1 minute, 2 minute, 3 minute, like that. So you can measure how much water is coming out in a minute. Okay, suppose if you place one measuring tank here or beaker, okay, and if you can start your stopwatch, and if the water is flowing, okay, in the and store in the measuring tank, and within a suppose 1 minute, if you stop your if you stop your timing, and within a 1 minute some amount of water will be stored in your measuring tank. So this will be, from there we can find out, you can find out the value of q, small q, that is discharge, that you can find out by measuring the volume, that is meter cube per unit time, whatever you have considered, that is 1 minute or 5 minutes, like that. Fine. And throughout the taste, this continuous flow water this flow water will be continuous. That means the particular this water tank, the level of this water always be there only, always remain constant throughout the taste. It will not going to decrease. Okay, that's why this h, that is this h means what? It is the hydraulic head, or the head difference between top and bottom. Here you can see the piezometer is fitted here to make you understand the difference in the head. Okay, since this is a continuous flow water, and since the water level and in at the top or overhead tank is always remain constant, the head difference between top and bottom will always remain constant. This h will remain constant throughout the test. That's why it is known as constant head flow test or constant head permeability test. Okay. Likewise, you can find out the value of q. Okay. So you can find out the value of k, that is coefficient of permeability of coarse grained soil, by using this formula. Q is your rate of discharge that you can find out in lab. Okay, this L is your length of the sample. Capital A is your cross-sectional area of the sample. It is already known to you. H is their constant head, which is always remain constant. So using this equation, you can find out the value of K for any kind of coarse grained soil in this constant head permeability test in laboratory. Okay. So next we'll discuss about falling head test. In case of falling head test, it is simply opposite of constant head test. Here the head will be decreasing throughout the test. Okay, the basic arrangement of the uh, setup of the experiment is almost similar. Here you can see you can use a similar kind of soil sample, but it should be a fine grained soil fitted between two permeable membranes, and finally At the top, one standpipe is fitted, not at the overhead tank. One standpipe. Okay, one standpipe having a standard diameter or standard cross-sectional area of small a. Okay, and at the bottom there is a bottom tank. Okay, finally water is stored in this bottom tank, and also you can add one measuring tank nearby the bottom tank so that the overflow from the bottom tank can be stored in the measuring tank. Okay, now in this particular falling head test, a definite amount of water is only used. Okay, a definite amount of water is only used. There is no such continuous flow water, and definite water will be coming through this standpipe, and water will flow in this soil. Okay, under gravity, and finally it will fill the this overhead tank. And to measure the value of q, you can place one measuring tank nearby this bottom tank, and the overflow of this from the water coming as an overflow from the bottom tank can be measured, can be stored in the measuring tank within a time. Okay, at how much time the water is coming. Okay, within a different time interval you can measure the value of q. Okay, in the measuring tank. Fine. So here you can see, suppose at the very beginning of the test, that is at the very beginning of the test, that is at the time of t equal to 0. That means you have just at the instant of start of the test. That means at t equal to 0 second or 0 minute, your initial head of water is this much. You can measure, say h1. Your initial head of water is h1. That means the head difference between top and bottom level h1 at t equal to 0. Okay, let's say after some time, say 5 minutes. After 5 minutes, what will happen? Since there is no continuous flow water, water will go down because water is coming through this soil sample and finally collected in the measuring tank. That's why the water amount of water will be decreasing. So head of water will go on decreasing. So at different time interval, suppose after 1 minute or after 5 minutes, you can measure the head or different head at different time interval. Likewise, you can find out h1 at t equal at t1, h2 will be a different time t2, like that. Okay, so other things will be similar. L is the length of the sample, and capital A will be cross sectional area of the sample, and small a is the cross sectional area of the standpipe. Okay, and you can go through this derivation. Okay, also you will get this derivation in the textbook also. You can also go through it. So I don't want to describe here, but if you got any confusion, you can also ask me, so I'll make you understand. But for now, you can directly get this value of K, the coefficient of permeability of fine grained soil, given as 2.3 LA. That is, L is your length of the sample, small a is your cross sectional area of the standpipe, log 10 of H1 by H2 divided by capital A into T2 minus T1. Capital A is your cross-sectional area of the sample, soil sample, and H1 is what? H1 is your any head, any head at time T1. H2 will be different head at different time T2. Okay. Likewise, get getting the value of H1 and H2 at different time interval T1 and T2, you can find out the value of K, that is coefficient of permeability for fine grained soil. Okay. Yeah, one more difference is there. This constant permeability test is take less time comparatively or compared to this falling head test. Since you know falling head test, fine grained soils are used, and fine grained soil have very small voids. So water take very larger time or long time or longer time to pass through the sample. Okay, compared to this coarse grain soil. So we can say constant at test is quicker than falling at test. Okay. So this is all about today class. We have discussed about these two laboratory tests to for determination of coefficient of permeability. Okay, uh, in laboratory. Okay, so from your book or by yourself, you find out what is the unit of coefficient of permeability. It is up to you. I am giving you a simple small homework to you. Okay, there is a unit for coefficient of permeability. I haven't given here, but it's find out. I'll maybe I ask next class. Okay, so find out the unit of K. What should be the unit of K? Okay, so it's up to you. You just find out in textbook. Okay, so this is all about today class. I just want to stop my sharing now. Is there any doubt? You can ask me now. Any doubt? अगर doubt नहीं है तो I'll just take your attendance then. ठीक है, I'll just stop my recording here first. Wait.